find this one here in Chegg. Maybe the numbers are the same. Maybe not. Let's see here. All right. All right. So an electric field is desired between two plates. The area of each plate is given. They're separated by some air, which is normal. Actually, there's no picture here, but they give you a formula here for this. So they say C equals epsilon naught A over D. And epsilon naught is 8.85 times 10 to the minus 12. The area is given. That's the 45. And then you got to convert that to meter squared. So there it ends up being 10 to the minus 2 squared to get that over 2.45 times 10 to the minus 3 to convert that one. So we're going to get some number for C. And then for Q is equal to CV. So we've got one part. So we're trying to find Q. Q is equal to C times V. V is equal to, we get that one calculation. V is equal to E times D. And E is given. That's the 9.5 times 10 to the 5th. And then your D is the distance between them, which is the 2.45 millimeters, but you have to multiply 10 to the minus 3 to get the conversion to meters. So we get those two numbers, and then we multiply them together. So this is where this class gets harder because it's these numbers don't mean anything and the values don't mean anything. But I'll see if I can get some of these in the calculator here for you.
I'll try to see if I can get the same equation.
Yeah. So this one ends up being approximately 1.63 times 10 to the minus 11. But you really want to store that value because you're going to use it here again. And then V is so this ends up being about 27.5. And then you take the two values and multiply them together. And I get
3.78.
Yep, times 10 to the minus 8. So maybe 3.8 times 10 to the minus 8 because I think it's just 2.
This in meters?
Coulombs.
Oh, coulombs. C?
C, yeah.
Perfect. On number 9.
So I see 17.54.
Well, this is the single. Yeah, 17.54.
I mean, I see a bunch here. So is there an order you'd like to go in?
17.54 next, please.
Okay. Okay, so the energy, how much energy is stored by the electric field between two square plates, 7.5 centimeters on each side, separated by a 2.3 millimeter air gap. So this is somewhat similar. Some of the equations. So 54 here. All right, so the This is so we're starting out with U equals 1/2 Q squared over C. We just have to find those values. Okay, so Q Q sorry, let me just do something real quick here. All right, so Q, actually they find A first, they find C first. So C is epsilon naught A over D. And you know that A is, the area is the 7.5 times the 7.5.
Mhm.
Okay, but then you have to convert. It's times 10 to the minus 2 squared, because you have to convert from the centimeters to meters. That's one of the really annoying things here, is you shouldn't have to do that many conversions when you're already doing pretty challenging problem. So
Yeah.
then the value of D is the where is D? 2.3 millimeter gap. So that's over. It's a 2.3. So that's the 2.3 times 10 to the minus 3. Yep. And then the epsilon naught E is that's the 8.85 times 10 to the minus 12. So that's the value for C. We'll get that. Q, we'll get Q next. So Q comes from, is Q given?
Wait. What does Q stand for again?
Q is given. It's the 13 nano.
Oh, the nanocoulombs.
Yeah. So Q is 13, and then we got to do some converting. So nano is 10 to the minus 6 squared, maybe. Nanocoulombs for Q, but we have to convert nanocoulombs into regular coulombs, which I think is minus 9. So it's 13 times 10 to the minus 9. Gets you back to, because I think nano is minus 9. So we finally have enough here
Mhm.
for these. So it's whatever this number is here squared divided by this number here, and then you take a half of it. So I'll get some of the intermediate calculations for you to help. And I'm sorry this is not better than it is, but this is all I got. 7.5 squared, 10 to the minus 4th over 2.3. So the first one here, this C is about 2.16 times 10 to the minus 11.
Okay.
So U is going to be 1/2 Q squared over C. So let's do. All right, so U is equal to 1/2 times Q squared divided by C. All right, so that's I get 3 point. That doesn't look right. Oh, I didn't square it. Did I not square it? Maybe that's because. Oh, because that one's in that. Okay. I don't really like this answer. I don't really like this answer at all, but
3.9 times 10 to negative 6. And what's the unit again?
it's
Coulombs?
joules, because it's
Oh,
energy.
joules. Okay. Incorrect.
What's that?
Incorrect, unfortunately.
Well,
We can move on to another one if this one's too much. Let's just keep it moving.
Okay,
We
can
don't
do
need to
that.
get stuck on this one.
Right. So let's look at the next one. The next one I have is 17.18. These will go better. These are like more like one step or one equation problems, the earlier ones. All right, so it says, what is the electric potential? 14 centimeters from a 4.5 microcoulomb charge. Okay, so that one's it's one of the equations we've already been using prior to, or in some of the previous ones here. So we're finding the electric potential. The electric potential is V. V equals KQ over R. And we have a bunch of these values. So K is the 9 times 10 to the ninth. Q is the microcoulomb there. So that's, what do they keep doing here? So 3 times 10 to the minus 6. Yeah, so this is 4.5 times 10 to the minus 6 for the microcoulomb charge, and then divided by R, 14 centimeters, so it's 14 divided by 100. Okay, and then the answer is in volts. So just got to do this multiplication out. This one's not too bad. All right, so I get 2.9 times 10 to the fifth volts.
2.9 times 10 to the fifth volts.
You might have gotten something that wasn't in this form, but I've just converted it to that.
That's correct.
Great. All right, we'll move on to the next one. Hopefully
1726.
Yeah, this is maybe a one stepper again. All right, how much work must be done to bring 3 electrons from a great distance apart to 6 times 10 to the minus 10 meters from one another at the corners of an equilateral triangle? So the charges end up like this, equilateral triangle. Where they come from? I mean, this is kind of it's one of those questions where you're like, well, how does this even happen? I have no idea where this comes from, because why would charges come together like this? But that's just additional commentary. Okay, so the work is defined here as, sorry, let me go scrolling too far. The work is the change in potential energy. The change in potential energy is Q delta V. Okay, and we know, and delta V is really V, so it's V is really KQ over R. Okay, so we have some of these values already, but there's a lot of things that go into this, blah, blah, blah. Wow, there's a lot going on here. So the what you end up doing, I don't quite follow this. There's quite a lot here. The solution ends up being, I'll just snip that in because that's probably all we care about at this point. It ends up being, snip this in here. They reduce the work down to this equation, and you have the same values. 6 times 10 to the minus. Actually, yours has a 6 there. So we just have to do this calculation with these new numbers.
Oh, okay.
Oh, syntax error. Okay. So I get 1.2 times 10 to the minus 18 joules when I do this. That might work.
What was it?
1.2 times 10 to the minus 18. It's just down here on the right.
Perfect. Let's go on to the next one.
Okay. All right. Next one is survey says, let's see here. Next one is 1735. Okay. Parallel plates. There are people who find this stuff really interesting, and this is the foundation of how all the electronic components that we use in the world work. So it's really important, but I don't think it's very clear
How it's taught.
how, yeah, and to learn it. There's just so many barriers to like understanding this. So okay, the amount of charge acquired by each plate is Q equals C times V. And they give you C, that's coulombs, and they give you V. So this isn't, I'm sorry, it's sorry, they give you V so you can find C. So they give you so, I'm sorry, I'm mincing words. C is Q over V, and Q is like the 2500 times 10 to the minus 6. That's the 2500 microcoulombs over 930 volts. That's your first value. Okay.
Okay.
Actually, that's all that's needed. Okay, so we got to do that calculation, and that's the capacitance in farads. So we'll get that number for you. So let me get that calculation for you. Why is it okay? 2500. 2.7 times 10 to the minus 6. And that's just capital F.
Excuse me. So 2.7. I'm still plugging it in. I'm being a little bit slow. All right, here we go. Correct. On the number 13.
All right, number 13. Get back to. All right, number 13. 17.37. How much charge flows from each terminal? So we're probably trying to find Q. We're given V and F. So we'll probably use that same formula that we just reasoned, but solving for a different variable. But of course, I'm going to just check because make sure to give you the right information. Yeah, so the formula here is Q equals C times V. We're trying to find C. Q, so we're trying to find Q. C is given, that's the capacitance, that's the 6.2 times 10 to the minus 6 microfarads, converting that to farads, and then volts times 16. That was not bad. It's just a one-step equation. So that's 9.92 times 10 to the minus 5, 9.9 coulombs, 9.92 times 10 to the minus 5.
All right, plugging that in. Correct. On to our last one.
All right, let's take a look here. $17.51. All right, so the we're trying to find V, and sorry, we're not trying to find V. We're trying to find the capacitance C. C is we have this from a Q equals C times V. C is equal to Q over V. So we got to find each of those, and that's the challenge here. Are either of these given? Yeah. So Q is given, but V is not. We gotta find V. So we know that E equals V divided by D. So we can solve for V. V is equal to E times D. E is the electric field, which we're given. That's the 8.2 times 10 to the fourth. And the distance is 1.9 times 10 to the minus 3, because we got to convert that millimeters to meters. 1.9 times 10 to the minus 3. So that gives us our V. We have Q, so we kind of have that done. So let me get this intermediate value for V and see if 10 to the fourth. All right, so it's about 156, which is reasonable. And so C is equal to, we're taking Q, which is 0.67 times 10 to the minus 6 over 1. It's actually 155.8 V divided by, oops, it's like I don't know what V is, capital V. Okay, wow, it's actually 1. Doesn't seem right. Oh, sorry, I did the wrong number. 0.67 times 10 minus 6 divided by V. So it ends up being 4.3 times 10 to the minus 9 farads. So try that for part A, 4.3 times 10 to the minus 9 farads. If that's right, we can do part B, because we need that answer for part.
All right. Putting it on in.
Did that work?
Hold on.
Okay.
Times 10 to the negative 9.
Yeah.
Still putting it in. F. Awesome, that worked.
Okay, so then the next part is we're trying to find the value of A. So for parallel plate capacitors, C equals K epsilon naught A over D. So we're solving for A. So A equals C times D over K epsilon naught. So we take that value we just got for C right there. We're going to use that value. So I'll just bring it up. 4.3 times 10 to the minus 9. the distance between, I think it's the distance between the plates, 1.9. Doesn't seem right.
I'm trying it out. So which one was it again? The
Well, we're using
4.3 again?
it's that number we just found for part A. That's the value of C. K is a known value. Um, it's the one that's given. It's the 3.75, and epsilon naught is 8.85 times 10 to the minus 12. And then why is it 0.001? I'm trying to figure out what's going on in this problem because it seems like it's okay. So it is the distance apart. Your distance apart is 1.9. So it's 1.9 times 10 to the minus 3. All right, so it's C times. So it used to be that you would get all this credit for doing all this partial work, writing everything down, and now they just grade everything based on right or wrong. So you gotta make sure this is correct.
I got so close to getting like the right answer, like on a test today, and it just was like 1 decimal off, and it
Yeah.
still marked it wrong.
So this is 0.246 meters squared. Yeah, that's where you almost got to go to your instructor and say, hey, look, I was just off here. Can you give me credit?
Mm-hmm. 0.246 meters squared. That's correct. All right. Check overview. That's everything I wanted to go through tonight.
Great.
Thank you, Matthew.
You're welcome. Have a great night.
You too. Bye-bye.